What's up, AP Calculus students? Mr. Ford here with another homework tutorial. This is for 4.3.2. We're doing problems for 119 all the way through problems for 126. And as you can see, I have crossed off a couple of them, so we'll not be doing all of them, just in the interest of time and moving on with our lives. For 119, we have the following integrals. We're going to consider multiple tools available for evaluating them and use the best strategy for each part. So this first one here, question A, I'm going to move off to the side there. We don't have the ability to evaluate this integral as it currently is, but if we were to expand out 2y minus 3 squared, we absolutely positively would. So that's what we're going to do. We're going to expand that all the way out. 2y minus 3 squared. This would give us 4y squared. We'd have a couple of 6y's, so it would be minus 12y. Plus 9. And so now we're looking for the integral. This is the general integral, the indefinite integral, if you will, of that expression there, which will be pretty easy to do because all we're going to do is find the antiderivative and then put a plus c on it. We'll start with y to the third power. We'll have to do 4/3 in front. That will cancel out and leave just the 4. Next, we're going to have minus, we have y to the second power. Let's put a 6 in front. 2 times 6 will give us 12. And then we'll have a plus 9y, and then we'll make sure we put a plus c on front of that thing. That will do the trick there nicely. Question B, it's tempting to find the antiderivative and plug in 2 and plug in 1, but we don't have the ability to integrate that function yet. In fact, we won't in this class. So what we are going to do is use the calculator, which we absolutely can do. No problems there. Integral from 1 to 2. Of 2 raised to the 3x power dx. And that will give us 26.93, and that's going to be our answer. I'm okay with that answer. I don't really... In fact, let's go ahead and look at D right now, because D is also going to be done the exact same way. We will eventually be able to integrate D this year, but not right now. So we're going to use the exact same strategy. We're just going to use the good old calculator to let that muscle handle a problem like this. Square root of 9 minus x squared dx. And it is a good idea to practice these keyboard commands because on a timed test like your AP Calc test, it's a good idea to just be able to do those things real quick. 7.0685 or so. 858. I'm going to stop there. And question C, I know I'm getting a little bit out of order on this one. Question C, I don't like this question because the answer is that we don't know how to do it yet. In fact, I don't believe you actually can integrate this at all. So this is not possible. And I don't think it's even not possible now. I think it's not possible in general, but more on that later on in your calculus life. And then you got question E, which we totally can do. Let's just think about anti-power rule or the reverse power rule. We're going to go m to the negative first power. We're going to go up a degree. And that means that we need this to be negative 9 in front, so it'll multiply to be positive 9. Then we're going to go up to m to the 12th power. And, a really easy way to do this is just go 7 over 12. That will do it. Because then the 12s will cancel out, leaving the 7. And we'll make sure we put a plus c on that as well. Do not forget your plus c. That's great. Typo. Calculate. Calculate the area of the region in the second quadrant under the curve x to the third plus 2x squared minus 3x. Let's first get an idea of what that is by graphing it. I think that's a good idea. So we're going to go on the calculator and we're going to graph x to the third power plus 2x squared minus 3x. And we're just going to carefully set the window here. We only care about the second quadrant. So is that what it says? Yeah, second quadrant. So let's go from like negative 10 to 0 and see if we can see everything there. I'll leave everything else the same. Just I want to get a good look at this thing, and then we'll see what we have to do afterwards. Hopefully we see something popping up there. Okay, area under the curve. Now, since they specifically said under the curve, I think what they mean is from this point to 0, right there. Now, we could have done some work with that to figure out we could have done some work with this polynomial to figure out that 0 of negative 3 right there exists, but we're just going to use the grapher now. So what I think we're going to go is we're going to adjust this a little bit. Let's go from negative 4, right there. I want to get a better look at it. So we're looking for that area right there. Now, since we now kind of know the boundary, really what we're going to do is we're going to turn this into an integration problem that we could do on the calculator, but we're not going to because we don't need it. we're looking for the integral from negative 3 to 0 of this function, x to the third plus 2x squared minus 3x. And so all we're going to do here is I'm going to put my graphing calculator away. We're just going to take the antiderivative, and we're going to plug in 0 and plug in negative 3 and do the subtraction. That's all we're going to do. So the antiderivative, I'm just going to put an arrow over here. This is going to be x to the fourth over 4 plus 2/3 x to the third power minus, let's see, 3 over 2 x squared plus, and that's it. That's all we got. We don't need to put a plus c on this thing. And we're going to evaluate this from 0 to negative 3. Now, it seems like a large task to do, but when you realize when you plug in 0, that whole thing just zeroes right out. So I like to break these up into two big chunks. The first chunk is just going to be 0, as discussed. I'm not even going to bother plugging in 0 to all four of those things. And then the one that's going to be kind of a pain, but we'll use the calculator for most of it. We're going to do negative 3 to the fourth power over 4 plus 2/3 times negative 3 to the third power minus 3 over 2 times negative 3 squared. So basically what we're going to do is whatever we get in that chunk, we're going to make it positive, essentially. So let's go for it. We're going to have, first thing is we're going to have in parentheses negative 3 to the fourth power over 4. We're going to do plus in 2 over 3 times negative 3 to the third power minus fraction 3 over 2 times negative 3 squared. And that's going to give us negative 44 over 4. I'm sure if we worked that all the way out, we probably could have gotten that by hand. But since this is 0 minus negative 45 over 4, we're just going to call it positive 45 over 4. And that's going to be the answer to that question. Neato torpedo. Okay, let's move on a little bit. Question 4.121. We're going to write each one of these following integral expressions as a single integral. We'll probably need some more room because there is not a lot for it here. Question A is not too tough to do, though. Looking at it, we have the same bounds, 2 to 9 in both of them. We just got f of x squared and then g of x squared. So all we're going to do is combine this into one integral from 2 to 9. And that's going to be f of x squared minus g of x squared dx. And that would be it. That's all we got to do there. For question B, we're going from 3 to 5 and then again from 5 to 9. So we can easily just combine these together into one integral going from 3 to 9 of f of x dx. Pretty simple. Now we've got one that's going to take a little bit more brain power to think about, I think. We got negative 2 to 1 right here. Negative 2 to 1. We've got 4 to 1, which is backwards. And then we got 4 to 9. So I think what we want to do here is we want to think about this as negative 2 to 1, f of x dx. We're going to change this into plus the integral from 1 to 4 of f of x dx, plus the integral from 4 to 9 of f of x dx. And there I think you'll see this is going to combine just into one integral from negative 2 to 9 of f of x dx. And that's it. Actually all combined nicely. And over here on question 2, again, we're going to be able to just combine these two integrals together pretty easily with no real problems. The 2 hanging out in front isn't going to do a whole lot. Although, in order to combine them together, what we should do is move it back inside the integral first so that it can kind of travel along with its companion. So this will be the integral from 2 to 8 of 2k of x dx plus the integral from 2 to 8 of j of x dx. And that's going to give us one integral from 2 to 8 of 2k of x plus j of x dx. And that's all there is to it right there. Okay, question. We're not going to do 122 because I don't really care about the limit form of a derivative much anymore. We saw it on the exam. We'll talk about that a little bit too. Anyway, 4.123. Refer to the graph to the right of f prime of x. Let's keep in mind that's the derivative. Where is f increasing? F increasing, f, the original function, is increasing when f prime of x is greater than 0. So that's going to happen. I see two ranges where that's going to happen. It's going to happen here at on this range there, and again on that little domain there. So that will happen from negative infinity all the way until negative 5. And then it'll happen again from, looks like 1 to 6. Those are the places where your derivative is positive, and therefore the original graph, f of x, is increasing. Approximate the interval over which f is concave up. Justify your conclusion with the graph. If f is concave up, what that means, let's think about this for a minute in question B. Concave up means that f double prime of x is greater than 0. And what that means is that its antiderivative, f prime of x, is increasing. So this becomes a question of where is this graph increasing? And I think that's happening on this domain that I'm making green right there. And I believe they said approximate because it's kind of tough to tell exactly where these points are. I'm going to guess about negative 2.5 to, I think, 4. I think that's a pretty good guess for question B. That's the x values on which the derivative is increasing, so therefore the second derivative is positive and the original function is concave up. Question C, is f double prime of 0 positive or negative? And explain how I know. Well, this kind of goes exactly with the question that we just answered. Since that graph is increasing, I wrote sing. Let me try this again. Since f prime of x is increasing when x is equal to 0, f double prime of x is greater than 0. That's a good way to say it. The derivative is increasing, therefore the second derivative will be positive. Let's go to 124. The horizontal flag is shown it right. We haven't seen a problem like this in a while. This is setting up for a big skill that will pay off later on. So we have horizontal flag shown it right. Imagine rotating the flag about its pole and describe the resulting three-dimensional figure and draw a picture on your paper. I'm going to go ahead and just doodle it right on top of this drawing. We'd kind of have like a cylinder like this, but there would be like an intersection like that would also be kind of like a bit of a cave. So it'd be kind of like, well, actually I'm describing the section that doesn't exist. So it would kind of look like this, but there would be these like pieces missing of it. So it would kind of like be almost like an hourglass, like where the sand is. There would be like a missing chunk there, I guess is what I'm trying to say. Imagine you took a cylinder, which is what this is. Essentially, it's a cylinder with a hole bored out of it all the way to the center. Like you would have almost hollow in there. I'm trying to draw my best artistic drawing I possibly can, but it's almost going to look like that, like an hourglass figure, like that. Now, as far as finding the volume goes, it's actually going to be a pretty simple process. If you think about it, what we have here, the volume is going to be the overall cylinder minus the two cones. So that seems like it's going to be kind of complicated to do. I don't know why my pen does that sometimes, but it didn't finish drawing the number 2. 2 cones. The cylinder minus 2 cones. So the cylinder, let's erase all these notes here and let's think about what's going to happen here. If I think about the shapes that are happening here inside of this drawing, the first thing for the cylinder, I know that the height is cylinder is pi r squared h. The height of that cylinder is going to be the h. That's the distance there. What I currently don't know is the height. Actually, I do know. It's not too hard to get. If you divide this into two triangles, you have a hypotenuse of 5. I know this chunk is 4 because it's got to be half of 8. And that means that this side here is 3. So the radius of that cylinder is going to be 3. So the cylinder is going to be pi times 3 squared times the height of h, or 8. Now from that, we got to think about these two cones. There are going to be 2 of them. They're going to both be in here, and they're going to be missing from this. The volume of a cone is, I should Google it really quick, but I'm pretty confident that it's, well, first of all, we have 2 of them. But the volume of a cone is 1/3 times pi r squared h. I'm pretty sure. 1/3 pi r squared h. I'm going to Google that really quick just to make sure I have it right, so I'm not wrong. The volume of a cone. Heyo, pi r squared h. Oh no! My tablet! It's broken! Oh no, I guess part 2 of this video is going to have to wait for tomorrow, guys. My tablet ran out of battery. I thought I could finish. Well, I'll see you tomorrow.